How did we accurately discover the sun's size and composition despite being unable to reach it? If you search Google for the size of the sun, you'll find it is estimated to be 1.41 times 10 to the 18th power cubic kilometers. If you look up the weight of the sun, you'll find its mass is approximately 1.89 times 10 to the power of 30 kilograms. As for the sun's composition, it consists of 74.9% hydrogen and 23.8% helium, along with trace amounts of other elements such as oxygen 1%, carbon 0.3%, neon 0.2%, and iron 0.2%. But have you ever wondered how scientists manage to determine the sun's size and composition with such precision, even though no one has ever reached or even come close to it? Calculating the size and mass of the sun. To calculate the size and mass of the sun, the first step is to determine the distance between the sun and Earth. Once this distance is known, the remaining details can be derived. But how did scientists measure this distance in the first place? The first person to address this question was the Greek astronomer and mathematician Aristarchus of Samos, who lived between 310 and 230 BCE. Aristarchus first calculated the distance between Earth and the Moon, then measured the Moon's diameter during a total lunar eclipse. Using these two pieces of information and applying trigonometry, he was able to estimate the distance between Earth and the Sun. Over centuries, astronomers like Johannes Kepler, Gottfried Wendelin, Edmund Halley, and others conducted advanced experiments, achieving increasingly accurate measurements. Today, the distance between Earth and the Sun is known to be approximately 149,597,870 kilometers, determining the Sun's diameter. To measure the sun's diameter, scientists use the principles of proportionality and geometry. For example, they placed a piece of aluminum with a small hole facing the sun and a white sheet behind it to project the sun's image. By measuring the distance between the aluminum plate and the sheet, as well as the diameter of the projected sun, and knowing the Earth-Sun distance, they used proportionality laws to calculate the sun's diameter. Understanding the sun's composition. To identify the sun's composition, scientists use the technique of spectroscopy. When an element emits light, it produces a unique spectral signature, much like a fingerprint. By analyzing sunlight using a prism, they identified the unique spectral patterns of hydrogen, helium, and other elements. Comparing these patterns with known data revealed that the sun primarily consists of 74.9% hydrogen, 23.8% helium, and trace amounts of other elements. Measuring the sun's temperature. To measure the sun's temperature, scientists use Wien's displacement law, which relates an object's temperature to the wavelength of its emitted light. Based on the average wavelength of sunlight, 493 nanometers, the sun's surface temperature is estimated at 5,605 degrees Celsius. The core's temperature is determined using nuclear physics principles, calculating the sun's mass. Finally, the sun's mass is calculated using Kepler's laws of orbital mechanics and the known densities of its elements. These calculations reveal that the sun's mass is approximately 1.89 times 10 to the power of 30 kilograms. In essence, this fascinating journey combines precise mathematical equations with advanced observational tools to unravel the secrets of our closest star.